last class, we discussed the reduction formulae. Now, more results are there in trigonometry which are very important. These results are trigonometric ratios of sum or difference of angles. See, sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Cos A plus B is cos A cos B minus sin A sin B. Cos A minus B is cos A cos B plus sin A sin B. Tan of A plus B is tan A plus tan B by 1 minus tan A tan B. Tan of A minus B is tan A minus tan B by 1 plus tan A tan B. Cot of A plus B, cot B, cot A cot B minus 1 by cot A plus cot B. Cot of A minus B is cot A cot B plus 1 by cot B minus cot A. That is cot B minus cot A. These results we use to find out trigonometric ratios of angles of the type 15 degrees, 75 degrees, 13 pi by 12, 11 pi by 12, 7 pi by 4, 7 pi by 6, etc. When such angles are there, we use the sum or difference of two standard angles. For example, to find sin 15 degrees, what we do is, this is taken as 15 degrees is not a standard angle, so we take this 15 as sine of 45 minus 30. 15 is taken as the difference of two standard angles. Now we use the result sine of A minus B. Sine of A minus B is sine A minus B is sin A cos B minus cos A sin B. So sin 15 degrees equal to sin 45 into cos 30 minus cos 45 into sin 30. This is equal to 1 by root 2 into cos 30 is root 3 by 2 minus cos 45 is 1 by root 2, sin 30 is 1 by 2. So this is equal to denominator is common 2 root 2 and the numerator is root 3 minus 1. Root 3 minus 1 by 2 root 2. So whenever you have to find out trigonometric ratios of 15 degrees, we take this as 45 minus 30 and the concerned result is used. So in this way you can find out tan 15 or any trigonometric ratios of 15 degrees. See, tan 15 is tan of 45 minus 30. 15 is not a standard angle. It is taken as the difference of two standard angles, and we use the result of tan of A minus B, which is tan A minus tan B by 1 plus tan A tan B. In place of A it is 45 and in place of B it is 30. So this is equal to tan 45 minus tan 30 divided by 1 plus tan 45 into tan 30. And tan 45 as well as cot 45 is 1. So 1 minus 1 by root 3 divided by 1 plus 1 by root 3, resulting in root 3 minus 1 by root 3 plus 1. And you can rationalize the denominator. No need for that. Now let us consider the angle 75 degrees. 75 degrees. To get sine 75 degrees, we take this as sine of 45 plus 30. 45 plus 30. 75 is not a standard angle. So we take this 75 as sum of two standard angles. Once again the result is used. Sine of A plus B we have sine A cos B. So this is sine 45 into cos 30 plus cos 45 into sine 30. And this is equal to 1 by root 2 into root 3 by 2 plus 1 by root 2 into 1 by 2. Once again, denominator is common, that is 2 root 2, and the numerator is root 3 plus 1. Root 3 plus 1. Now, when we have to solve problems involving radian measure, for example, 13 pi by 12. This is a radian. Here what we are using is numerator is 13 with the pi, denominator is 12. So we write this 13 as the nearest multiple of the denominator plus pi, and this is pi plus pi by 12. Both chains are divided. Now to get sine of 13 pi by 12, this is taken as sine of pi plus pi by 12, and sine pi plus theta is minus sine theta. In place of theta it is pi by 12. So it is minus sine pi by 12. Here we have a question to prove that 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 6 square pi by 3 equal to 10. Now out of the angles, 3 pi by 4 is not a standard angle. So what we do? 3 pi by 4 is taken as 4 pi minus pi by 4. 3 is taken as the nearest multiple of 4 minus pi, and this is equal to 4 and 4 cancelled, pi minus pi by 4. Now sine pi minus theta is sine theta. Therefore sine 3 pi by 4 equal to sine pi minus pi by 4, which is equal to sine pi by 4, that is 1 by root 2. 1 by root 2. Now let us go back to our question. And what is the question? LHS is 2 into sine 3 pi by 4 the whole square plus 2 into cos pi by 4 the whole square plus 2 into sec pi by 3 the whole square, and this is equal to 2 into we got this as 1 by root 2. Its square is 1 by 2 plus 2 into 1 by root 2 in the square plus 2 into sec pi by 3 is reciprocal of cos pi by 3, which is again 2. So this is 2 square. 2 and 2 are cancelled. The remaining is 1 plus 2 into 4, 8, which is equal to 10, and that is the RHS. That is the RHS. Let us try one more question. Cot square pi by 6. Cot square pi by 6 plus cosec 5 pi by 6 plus 3 tan square pi by 6 equal to 6. The only one angle which is not in the standard form is 5 pi by 6. So we take this 5 pi by 6 as nearest multiple of 6 minus pi by 6. This is pi minus pi by 6. Pi minus pi by 6. And there we have to use cosec pi minus theta, which is equal to second quadrant, is cosec theta itself. Therefore, cosec 5 pi by 6 equal to cosec pi by 6. Cosec pi by 6 sin pi by 6 is 1 by 2. Its reciprocal is 2. Now let us go back to the question and LHS is cot pi by 6 the whole square plus cosec 5 pi by 6 plus 3 tan square pi by 6. This is equal to cot pi by 6 is root 3 plus cosec 5 pi by 6, we got it as 2 plus 3 into tan pi by 6 is 1 by root 3. Its square is 1 by 3. So this is equal to root 3 square plus 2 plus 1, which is 3 plus 2 plus 1, that is 6, which is the RHS. So this is the use of reduction formulae in solving problems. Also, we have to use the ratios of sum and difference of angles. If 15 is given, we take this as 45 plus 30. If 75 is given, we take it as 45 plus 30. If 3 pi by 4 is the angle, we take it as 4 pi minus pi by 4, which is equal to pi minus pi by 4. If you are given 7 pi by 6, it is taken as 6 pi plus pi both by 6, which is equal to pi plus pi by 6. So this is an important topic from which you can expect at least one question. So we wind up today and we shall see with a new set of questions in the next class and see from trigonometry, which is considered as a toughest topic, you can score full mark, that is an assurance given by me. Okay, thank you.